Welcome to solving exact equations. So the idea here, if we have exact equation, so if we have exact equation, m dx plus n dy equals 0, right? Then the solutions take the form f of xy equals c, constant, where fx is equal to m and fy is equal to n. And so what we can do is we can essentially integrate m with respect to x or integrate n with respect to y, and then do a little additional work to figure out an f that meets both of those requirements. So we'll integrate m with respect to x or n with respect to y. And then the only thing that sort of might change is how that constant works. So, and then we'll do a little work with the plus c component. So let's go ahead and start off with the equation 8x cubed y cubed plus e to the x dx plus 6x to the fourth y squared plus 4y dy is equal to 0. I tell you here that this is exact, but we can always check that it's exact. So let's go ahead and check that it's exact. So let's take the partial with respect to y of that first piece, 8x cubed y cubed plus e to the x. And partial with respect to y, 8x cubed comes along for the ride. Y cubed would go to 3y squared. So we have our 24x cubed y squared. That component is the same as the example we saw in a previous video. The second part we changed a little, but if we take the partial with respect to x, of 6x to the fourth y squared plus 4y. The 4y would go to 0. There's no x involved. 6x to the fourth y squared. The 6y squared is acting like a constant. And x to the fourth would go to 4x cubed. So we again get 24x cubed y squared. These are equal. And so we have our exact. So we can choose whichever one of these we want to work with. We can either start with the 8x cubed y cubed plus e to the x, or we can start with a 6x to the fourth y squared plus 4y. For this problem, let's go ahead and start with the 8x cubed y cubed plus e to the x. So what we have is for a solution, f of xy equaling c. We know that the partial with respect to x of f should be that m, so it should be 8x cubed y cubed plus e to the x. So we're going to sort of treat y as a constant and integrate with respect to x. So we get f of xy is equal to, we'll take the integral of 8x cubed y cubed plus e to the x with respect to x. Now we're taking an indefinite integral, which means we get a constant. And that constant might change depending on what our y value is. So we do our indefinite integral. With respect to x, 8x cubed y cubed would go to 2x to the 4th y cubed. E to the x just goes to e to the x, and here's our weird plus c. So we're going to add on a function of y. Essentially, this is acting like our plus c. So this is acting like plus c. But we may have a different plus c for each value of y. So again, when we did the integral, we were treating y like a constant. So we essentially just did infinitely many integrals for each possible value of y. And for each of those possible values of y, that integral comes with its own plus c. So I'm going to give myself a little more space, and then I'll show you how we figure out what that psi of y is. So continuing from here, we have that f of xy is equal to 2x to the 4th y cubed plus e to the x plus psi of y. Now, since we used the partial with respect to x earlier, we also know we're going to use the fact now that the partial with respect to y of xy should be equal to, what was that? 6x to the 4th y squared plus 4y. That was my n. So if we take the partial with respect to y from here, we get that f, the first partial with respect to y of capital X evaluated at xy should be, that y cubed will go to 3y squared. So we have 6x to the 4th y squared. E to the x will go to 0. And then psi of y would be psi prime of y. So this should be equal to our other first partial with respect to y that we got from n. So this should be equal to 6x to the 4th y squared plus 4y. So what this means then is that psi prime of y should be equal to 4y. And therefore psi of y should equal 2y squared. So what our final solution winds up being, we have f of xy is 2x to the 4th y cubed plus e to the x plus 2y squared. And that gets set equal to constant c. So our solutions take this general form, 2x to the 4th y cubed plus e to the x plus 2y squared equals c. So we have one more equation. Let's go ahead and verify that 12x cubed e to the y minus y sine of x, all of that times dx, plus 3x to the fourth e to the y plus cosine of x, all of that times dy equals 0. Let's verify that equation is exact. So first, we're going to check that it's exact. So we're going to take our m, 12x cubed e to the y minus y sine of x, and take that partial with respect to y. So take the partial with respect to y of 12x cubed e to the y minus y sine of x. Taking that partial with respect to y, 12x cubed comes along for the ride, and then we just get e to the y. And then minus y times sine of x. Sine of x is acting like a constant, so this just becomes minus sine of x. Now we'll do the same thing, taking the partial with respect to x of our n. So partial with respect to x of 3x to the fourth e to the y plus cosine of x. Treating y as a constant, 3e to the y acts like a constant. X to the fourth will go to 4x cubed. That becomes 12x cubed e to the y. Derivative of cosine x with respect to x is negative sine of x. So we do have that these two pieces are equal to each other. And so we have exact. From here, we pick one of those functions. You can pick whichever one you choose. Last time, let's see, we used m in integrating with respect to x. So why don't we go ahead and use n and integrate with respect to y this time? So to solve, the solution will take the form f of x, y, oops, capital F of x, y. Let me rewrite that so it's not messy. All right, capital F of x, y is equal to c. And we're going to use the fact that the partial with respect to y should be our n. My screen froze, one moment. All right, so we know that the partial with respect to y of f is n, and the partial with respect to x is our m. So let's go ahead and use this first piece. So we have the partial with respect to y, evaluated x, y, should be equal to 3x to the fourth e to the y plus cosine of x. So now, since that's the partial with respect to y, we're going to integrate with respect to y, and we will treat x as a constant. So we have f of xy should be equal to the integral of 3x to the fourth e to the y plus cosine of x dy. Again, we're going to treat x as a constant. When we take this integral, we will have integrating with respect to y. This just is 3x to the fourth e to the y. 3x to the fourth acts like a constant. Integral of e to the y is e to the y. Cosine of x is acting like a constant. So we should wind up with plus y cosine x. And then again, we have a constant, and our constant will vary depending on which x we are working with. So once again, our plus c depends on the value of x. So again, viewing x as a constant, we were taking a whole bunch of different integrals. And so that plus c will depend on the value of x. So now we're going to use the fact the partial with respect to x, the one we have not used yet, is equal to m, or an m was 12x cubed e to the y minus y sine of x. So we know f of xy is equal to 3x to the fourth e to the y plus y cosine of x plus psi of x. The partial with respect to x is therefore 12x cubed e to the y plus y derivative of cosine x would be negative sine x, so this will become minus y sine of x plus psi prime of x, and that should be equal to what we found over here. So this should be equal to 12x cubed e to the y minus y sine of x. Well, to make that true, we can simply take that psi prime of x is equal to 0. And then we need just one value of psi of x, or one function for psi of x, so we can take psi of x equal to 0. We just need one f of x, we just need one psi of x. So I guess we should say technically we would get psi of x is c, but then we can use psi of x equals 0. So at this point, we have f of xy is equal to 3x to the fourth e to the y plus y cosine of x. We have plus 0, we don't need to write that. And we set this whole thing equal to a constant c. So this is our general solution to that exact equation. So as you saw, when we have an exact equation, you just pick your m or n, integrate with respect to its respective variable. Just be sure that your plus c takes the form of a function in the other variable. Then you can differentiate to figure out what that missing function should be.